So can you think of any combinations where you know three things, sides, angles, whatever, where you couldn't use the law of sines? So like looking back at this triangle, if I knew three things, any three things, angles, sides, or combinations of angle and sides, are there any way that I could do that where I wouldn't know an angle and a side across from it?
If you had just three measures of the angle.
Okay, so if we had what we would call angle, angle, angle. Yep, that wouldn't work. What else?
All sides.
All sides. We had side, side, side.
One angle, two sides.
Yeah. If you had a side, an angle, and a side, and the sides you knew were not across from the angles that you were given. The side, angle, side. So those are three instances where you couldn't use law of sines. So obviously we need another law. So that's why you have here the law of cosines. Law of cosines you hardly ever start off with. Law of sines is easier. So if you can use law of sines, you should use law of sines. But sometimes in these three situations, you have to use law of cosines. So here's what they are. If you have, we can call it a squared, that's one of the little sides, squared, is equal to the sum of the other two sides squared. So right there it kind of looks like the Pythagorean theorem. Then minus 2bc, so those same two sides, the b and the c, and then times, since it's the law of cosines, the cosine of the big angle that matches the little side that's across from it at the very beginning. Now there's three different versions of this, but it's just rearranging the letters. So like if I had b squared, then what would be the two sides?
A squared.
Yeah, a squared and c squared. Minus 2 AC times the cosine of b. Yeah, big B. And little c squared be a squared plus b squared minus 2ab times the cosine of c. So I actually just use one of those formulas and then just go from there. So these are two different problems, A and B. We'll start with the one over here on the left, A. Notice this is a side, side, side kind of thing. Again, they don't have to be drawn to scale. I'm trying to get it, but it's just not going to happen. So little a is 6, so that's the side across from big A. Little b is 4. And little c is 9.
Does it matter where we put that ABC?
Not at all. As long as little a is across from big A, little b is across from big B, and little c is across from big C. Good question. So when we're asked to solve for the triangle, what we're missing is angle A, angle B, and angle C. So which one do you want to find first? A. Okay, sounds good. So if we're trying to find angle A, then I got to start with little a. I'm just going to write the formula first, because that's the only formula that has big A in it. So that's why I had to use that formula if we're trying to find little a. It really doesn't matter which one you find first. So it's just a matter of plugging things in. We know little a is 6, and b is 4, c is 9. $36 equals 16 plus 81. 72 cosine of A. Here's what happens every year. People will do 16 plus 81 and then go ahead and subtract the 72. Can't do that. Order of operations says I've got to multiply the 72 times the cosine of A before I can subtract it. So all I can do right now is add the 16 and the 81, which is what? 97. I cannot subtract 97 minus 72. That's not following the order of operations. I can subtract 97 from both sides of the equal sign. You get 36 minus 97, get negative 61. Questions? Sometimes that loses people. Okay. Trying to get cosine of A by itself, so you divide by negative 72. Negative divided by a negative, we know is a positive. So I just went ahead and put positive. That's okay with everybody. And then how do I find A? Inverse cosine, yeah. So we're going to do the inverse cosine of 61 over 72, and that will be A. What did you guys get for A? Yep. I'm going to write that in for A up here. Okay, 32.089. So to practice law of cosines, I'm going to keep doing law of cosines. This time let's do B. B squared equals A squared C squared minus 2AC times cosine of B. Now I know technically you could do the law of sines now because I have an angle and a side across from it, but I would be using a rounded answer. I wouldn't count that wrong though if you did it, but I just want us to practice law of cosines because it's a little bit harder than the other one. Okay. So it's 4 squared, 6 squared, plus 9 squared. Again, don't take 36 plus 81 and then subtract 108. Happens every time. So. 117 minus 108 times cosine of A. Subtract 117. Oh, I don't know why I keep putting A. That should be B. Sorry. How did I guess from what we did before? Divide 101 divided by 108. Negative over a negative is a positive. Inverse cosine. I got 20.742. Okay, you want me to look at it?
I actually put 108 instead of 101.
Oh, okay. Yeah, when you add 108, it makes it 101. Or, sorry, subtract 117. It makes it 101. Okay, so it's 20.742. That's B. And now that we have two of the angles, we can subtract those added together from 180. We got 127.169. Okay, so all we have left is little part B left. I'll probably upload little part B, but it's the exact same thing that we've been doing. So you should be good for the homework, day 63 and 64.